Hi, and welcome to another exciting edition of CG Shader Programming. My name is Nate Nestler, and this is for Hyperactive Studios. Alright, so before we went over the theory of normals and normal mapping and, well, displacements, height maps, bump maps, etc. Release mapping, parallax mapping, blah blah blah. Okay, so lots of things, right? So let's start going over normal mapping. So I showed this off earlier in the theory video, but you really need to see, it actually working on the model. And I just grabbed one of the textures that was sitting in the thing. I guess it has a video on it. I don't know. It's pretty cool. And so basically, what do we do here? Okay. Well, we have, let's break this down. So I've made this actually a while back, actually quite a while back, and then I updated it. So I made it probably like, I don't know, well, about 8 months ago, yeah. But then I went and optimized it some. So here we go. Let's go with that. So if you were looking at your previous phone texture with diffuse or something like that, be the same one with that without the reflection. Phone texture with diffuse reflection map. Yeah, that one from previous videos. It'd be pretty much just like that one. So if you want to take that one, come over here to create effect and CGFX. If you don't have that, it's okay. I'm going to go through the entire thing here. So but preferably you just copy and paste that so you don't have do a whole lot of extra work. We're getting more and more advanced with our shaders, so saves a lot of time if you just copy and paste stuff. Alright, so float 4x4 here, world view projection colon world view projection. This is always the same here. Open greater than sign. Well, actually, that's open less than sign. Yeah, open less than sign. String UI widget equals none in quotes here, semicolon. Close greater than sign, semicolon. Float 4x4 world ITX F here, colon. World inverse transpose. I just did this because this is the popular way to do it. They have a lot of shader examples, so they all just like to use this naming for it. So whatever. Open less than sign, string UI widget equals in quotes none, close quotes, semicolon, greater than sign, semicolon. Float 4x4 here, world XF here, colon world. Open less than sign, string UI widget equals in quotes none, semicolon. Again, we just don't want these to show up in the interface over here, so that's what we're doing. And then close greater than sign, semicolon, float 4x4 float 4x4 view ITXF colon view inverse here, open less than sign here, string UI widget equals in quotes none, close quotes, semicolon, greater than sign, semicolon here, artist controls here. Alright, so we have our point light here, const float 3 lamp 0 pose colon position, open less than sign, string here, object equals in quotes point light 0 close quotes semicolon, string UI name equals lamp 0 position close quotes semicolon, string space equals in quotes world close quotes semicolon, and then close greater than sign here. And here we go. Alright. And that'd be float there for well, this is just the position of the light, and then right here's the color for it. So this is nothing new really. Const float 3 lamp 0 color colon specular. Of course, this revolves around my current point light in the scene. String UI name here equals in quotes lamp 0 color close quotes semicolon, string object equals in quotes point light 0 close quotes semicolon, string UI widget equals in quotes color close quotes semicolon, and then closing greater than sign equals curly brace 1.0f comma 1.0f comma 1.0f close curly brace semicolon. And then we have our ambient light, const float 3 here, global ambient, colon, ambient, open greater than sign, string UI name equals, in quotes, ambient shadow, close quote, semicolon. And again, this is for doing our ambient shadow. But I think, oh, what the heck, I'll just leave it like that. Okay. So there's your ambient shadow. And then we have our KA. And remember, KA is going to be our ambient color here. So const float for KA colon color. And then we're doing our annotation. So open lesson sign here, string UI widget equals, in quotes, color, semicolon, string UI name equals, in quotes, ambient color. Sorry, extra space. Close semicolon here. Open greater than sign equals curly braces 0.8f comma 0.8f comma 0.8f comma 1.0f close curly brace semicolon. Const float 4 here kd colon color. Open greater than open less than sign, sorry. String UI widget color, string UI name equals, in quotes, diffuse color. I just have that extra space in all of them. Semicolon, open greater than sign equals, open curly brace here, 0.8f, comma, 0.8f, comma, 0.8f, 1.0f, close curly brace, semicolon. And this sets us up for our KD for our diffuse color, which is pretty much standard. We're just doing a Phong shader here, guys. At this point, Phong should be very familiar with you. Float for KS colon color. Open lesson sign string UI widget equals, in quotes, color, close quotes, semicolon. String UI name equals specular color, close quotes, semicolon. Close greater than sign here equals open curly brace here 0.8f comma 0.8f 0.8f 1.0f close curly brace semicolon. So it sets us up for KS for specular. You definitely want this kind of stuff, especially when you're doing with these Phong shaders, especially if you're doing like these normal maps. Don't get me wrong, you know, a normal map with some Lambertian shader, but you know, it's nice to have some specular. Alright, and then we have our spec power here. Const float spec power here, colon specular power, open lesson sign here, string UI widget equals slider, in quotes, semicolon. Float UI min equals 1.0, semicolon. Float UI max equals 128.0. Semicolon, float UI step equals 1.0, semicolon, string UI name equals, in quotes, specular power, close quotes, semicolon, open greater than sign equals 55.0, semicolon, const here, and I guess I still have my reflection strength. So this doesn't need to be there for this particular one. Oh, wrong shader. Okay, well, it's all the same code. Nothing changes, except we just don't have that, we just don't have the reflection one there. So if you're working from the reflection shader from before, that's cool. It's perfectly fine. We're just going to take out that KR one there and go from there. So it's just going to be minus the KR, and then we're going to add it back here later. You know what, I'll tell you what, since people are going to be coming from the reflection one anyways, let's just go from the reflection one, because it's not making a difference right now. So here, wrong one. Let's see here, 1 second. Let's just go with the reflection one, basically, where it has and somehow ended up in the wrong place. Oh, goodness gracious. No, not that one. Alright. Alright, yeah, so we're just going to do this one. Instead of just doing the regular normal one, we're going to do the normal one with reflections because you already had a reflection shader from before. And then we'll just take out the reflection part of it for making a regular normal map one. So we'll do that. So here we are. We've been coding this one with the reflection the whole time. Let's just continue on with that. And since you guys have reflection shaders already from the previous video, it'd just be easier if we just continued on from this point. So essentially, so we do need the reflection annotation here now. So const float kr here, open less than sign here, string UI widget equals slider here, float UI min equals 0.0 semicolon, float UI max equals 1.0 semicolon, float UI step equals 0.01 semicolon. Note this is the exact same shader we were doing earlier, so we're still on the same one. String UI name equals reflection strength in quotes here, semicolon, open annotation. I hate when I do that. Yeah, that one also needs to come down here. Sorry. Pet peeve. It makes it much harder to tell where statements begin and end if you have them up here on this side. I hate when people code it up there like that. Just it's visually harder to read. More likely, I think, be prone to error. But anyways, string here, UI name equals, in quotes here, reflection strength, close quote, semicolon, close greater than sign equals 0.5 semicolon, const float normal bump here, open less than sign, string UI widget equals, in quotes, slider, close quote, semicolon. So now we have our reflection strength over here. Cool. And then the next one we're going to do here, and that's what our KR is. Remember, it's the same one from our reflection model from last time, from the last set of videos here. And let's look at something else here. Let's just go for our normal bump here. So const float normal bump. At this point, and remember what a normal bump does. A normal bump is going to let us change our detail on our surface here for our normals. It's like magic, man. This could be used for cool effects too in the game. You know, like suddenly have someone grow old. That'd be so cool. You could do it with this. It'd be neat. Alright, of course you'd want to animate a few more shaders more than just normal, but yeah, it'd be cool. Like diffuse, and yeah. Alright, so here's normal bump, open less than sign, string UI widget equals slider, in quotes, float UI min 0.0, float UI max 5.0, float UI step 0.01 semicolon, string UI name equals normal bump in quotes, semicolon, close greater than sign here equals 1.0 semicolon. Let's hit up our textures. So we're just going to do the diffuse texture with this one. Texture here, color texture, open less than sign, string resource name equals, I don't know, just default underscore color dot DDS, close quotes, semicolon, string UI name equals, in quotes, diffuse texture, in close quotes, semicolon, string resource type equals, in quotes, 2D, close quotes, semicolon, close greater than sign, semicolon, sampler 2D color sampler equals sampler underscore state, open greater open curly brace here, texture equals open greater than sign, color texture, close greater than sign, semicolon, min filter equals linear, mipmap linear, semicolon, mag filter equals linear, semicolon, wrap S equals repeat, semicolon, wrap T equals repeat, semicolon, so that way we can, you know, basically repeat across our UV space, so we can repeat an image multiple times. So this diffuse one can actually be repeated many times across the surface. Right now we're not doing that, but we can do that. texture normal, our normal texture. So this is the texture that's going to provide us this, well, this distorted bump here along the surface that looks so awesome. So texture here, space, and then normal texture, and then open less than sign here, string resource name equals in quotes default underscore bump underscore normal dot dds close quotes semicolon string UI name equals in quotes normal dash map. I decided to put a dash in there apparently. And then space texture. Here, close quotes, semicolon. Probably has to have that dash. Oh well. I don't remember anymore, but I guess, like I said, this is a long time ago. String here, resource type equals, in quotes, 2D, close quotes, semicolon. Closing greater than sign, semicolon. Sampler 2D, normal sampler equals sampler underscore state. So again, this is our normal texture. And then we need to actually get the individual pixels from it to be processed. And so we're grabbing individual pixels with our sampler state here. Curly brace here, texture equals open greater than sign, normal texture close greater than signs, greater than less than signs, whatever. Semicolon, min filter equals linear, map linear, semicolon, mag filter equals linear, semicolon, wrap s equals repeat, semicolon, wrap t equals repeat, semicolon. Just to get this stuff done faster, just take the first texture that you code up here and then copy and paste it if you're not using this from another one. So that way you're not typing this all out bit by bit, because otherwise it's just a lot of extra wasted effort. And just make your slight little changes here, you know. This and like this. That's all you'd have to do. So, you know. This one too. But that's about it. Okay. And then environment texture here. So texture, environment texture, colon, environment. Open less than sign, string resource name equals default underscore reflection dot dds in quotes, semicolon. String UI name equals environment, close quotes, semicolon. String resource type equals, in quotes here, cube, semicolon. Close greater than sign, semicolon. Sampler cube, so we need to, that pulls up our cube map image over here for our environment image, but we need to also be able to access the pixels on the surface of that image. So how we do that? Well, we're going to have to do that with our sampler cube. Sampler cube environment, EMV sampler, because I like calling it that, so I know it's the environment one, equals sampler underscore state here, curly brace, open curly brace here, texture, equals open less than sign EMV texture close greater than sign. Of course that matches this one here as always. Semicolon, mag filter equals linear, semicolon, min filter equals linear, map linear, semicolon. Wrap s equals clamp to edge, semicolon. Wrap t equals clamp to edge, semicolon. Wrap r equals clamp to edge, semicolon. Curly brace, semicolon. Alrighty, moving on. So in out parameters here, and we have data from application vertex buffer here. So struct vs_in, open curly brace here, float 3 position colon position semicolon, float 4 UV colon text chord 0 semicolon, float 4 normal colon normal semicolon, float 4 tangent colon tangent 0 semicolon, float 4 binormal colon binormal 0 semicolon, close curly brace semicolon. Struct vs out here, open curly brace here, float 4 position colon position semicolon, float 2 UV colon text chord 0 semicolon, float 3 LWN colon text chord 1 semicolon, float 3 NWN colon text chord 2 semicolon, float 3 VWN colon text chord 3 semicolon, float 3 TWN colon text chord 4 semicolon, float 3 BWN colon text chord 4 float 3 BWN colon text chord 5 semicolon. Now this is our binormal. So here we have our tangent vector. Wait a minute, do I even use binormals in this one? Wait a minute, I think I do. I think I do. I should be using binormals. Yeah, I do. Okay. Sorry, just making sure. Don't trust myself. Alright. Well, it should be text or map. Yeah, I do. Okay, making sure. Yeah. I've been reading a whole bunch of the relief shader mapping and binormals with that and everything, and I'm sitting there going, obviously, yes, I do use binormals with it. So, but yeah, you have binormals on both of them. So we have our binormal here for our VSN, and also for our text chord or vector space. And of course, you have to have binormal in order to do the normal, binormal, and tangent coordinates. So of course, you'd have to have it for normals. I'm not thinking. Still running off of barely any sleep. All right. So here we have struct fs out here, open curly brace here, float 4 color colon color semicolon close curly brace semicolon. Vertex shader, vs out, main vs, open parentheses, vs in, space in, close parentheses, curly brace here, vs out, space out, semicolon, float 4, po equals float 4, open parentheses, in dot position dot xyz, comma 1, close parentheses, semicolon, float 3, pw equals mul for multiply, open parentheses, world xf, comma po for object space position here, and then close parentheses dot xyz. All right, and then I'm saying, you know, the whole multiplying by the world inverse transpose coordinates allow for non-uniform scaling, which is not possible if you use the world coordinate space, which is a really cool solution. So you know, that's been around there for a while for the comments, but I keep using them. Out dot normal here in world coordinates, that's been normalized. So we're going to normalize that. So we're going to multiply our world inverse transpose matrix times our normal vector, and then so that's going to get normalized as an xyz. And then also we're going to do it with our light one here. So out dot lwn equals normalize, open parentheses lamp 0 pos minus our world coordinates here, our position world coordinates, close parentheses semicolon. So that gets normalized. So we end up with our light position and world coordinates with it's been normalized. And then out dot vwn equals normalized here, float 3, and then view x ixf, sorry, open brackets here, 0 close bracket dot w comma view ixf, open bracket 1 close bracket dot w comma view ixf, open bracket 2 close bracket dot w close parentheses minus pw close parentheses semicolon, out dot twn, which is going to be, so that was our view for our camera. So this is our view vector here, and it's going to come out in world space coordinates, and it's going to be normalized. And then we're going to do our tangent now. So we have our normal up here, but we need to get our tangent now. So how do we get our tangent? Well, real simple. We just pass it in. So out dot twn and tangent and world space coordinates, it's been normalized. We're going to multiply our world inverse transpose coordinates matrix here times our tangent here, close parentheses dot xyz here, and so that's going to give us close parentheses semicolon. So that's going to give it to us our tangent and world space coordinates. It's going to be normalized. We need to do the same thing with the binormal too. So out dot binormal in world space coordinates has been normalized. So that's what we're going to do. We're going to do that now. So we're going to normalize it, and we're going to do what? Multiply our world inverse transpose matrix here times our binormal. So these just came right on in. And then close parentheses dot xyz, close parentheses semicolon. So that's pretty cool. We really didn't even have to find them. It just came right into the application from an external parameters here that's passed in. Okay. And then out dot position equals mul here for world view projection, comma PO here, close parentheses semicolon, out dot UV equals in dot UV dot XY semicolon, return out semicolon, curly brace. Okay. So with that, that gives us our position out of here, and we get our UVs we're getting passed out, and then we return the whole structure. And then we're going to pass that in to our FS shader here, our fragment shader function for a pixel shader. Same thing, whatever. Okay, so FS out semicolon, so this is going to be our returning one. Remember, it's just going to return color as a float 4 here. And then our VS out space IN, capital N, is going to be coming as N. So float 3 here, RN, which is our reflection value here. It's going to be, honestly, this should have been done on the other end. Oh well. This one, to be more efficient, honestly, if you want to speed things up a bit, you would have it over here instead of over here, because this is inefficient having it right here. There's really no need to do that on this end of things. It could be done over here, and I don't think we're passing it in and out. Yeah, we're not. So why is this thing, if you want to go back later here, I think I do this in the reflection shader. This should be moved out of here and put into the vertex shader to make it faster, because you want it in here, so it's not going to do the calculation over here and then pass it over into the pixel shader, because that's not as efficient as it could be. But yeah, anyways, float RN in reflection vector in normal. It's been normalized. It's in dot view in world space coordinates. It's normalized, plus our light vector here. It's been world space coordinates. It's been normalized. Add those together, and we have to normalize them again, because there's a potential, since they're both been normalized, they have a 1.0 capability for its magnitude, but if we add them together, we end up with a magnitude of 2.0, so we need to make that magnitude back to 1.0 again. So we have to normalize it, because otherwise our magnitude would be too high, and we get undesirable results, because again, we just want just the direction and none of the strength of the actual vector. Float 3 here, norm equals normal bump here times, and then this is our vector for, not our vector, sorry, but this is our value here for controlling the strength of a bump. So if you remember that, okay, cool. So we're taking that variable strength here, and we're multiplying it times a result of our text2D normal sampler, where we bring in our pixel here, in.uv here, close parentheses, .rgb minus float 3, 0.5, 0.5, 0.5, close parentheses, semicolon. Now where did that come from? Okay, now remember our happy mathematics over here. What we would do when we want to go from the texture back to normal, back to actual physical normals. So what we have to do, we have to subtract it by 0.5, and we have to subtract it by 0.5 per component. So this would be X, Y, and Z. Or in the case of an image, they'd be RGB, red, green, blue. That's what's happening here. So we're subtracting 0.5 from red, 0.5 from green, and 0.5 from blue here. So would that be subtracting basically 0.5 if you want to when you convert this from color to an actual positional vector? This would be X, Y, and Z. So essentially we are subtracting 0.5 from X, 0.5 from Y, and 0.5 from Z. Because remember, red is going to be X, green is going to be Y, and blue is going to be Z, your Z-axis. Okay, so be aware of that. And that is what we're doing there. Okay, and then we're modifying it for the strength of it by multiplying it times this constant annotation here that's used throughout. All right, so in dot normal a vector here that's been created in world space coordinates and it's been normalized. So in dot normal in world space coordinates that's been normalized plus norm dot x times in here dot twn. So we're adding a whole normalized direction to it, and then we're also doing, because we're modifying our other one, our regular normal here, because remember we still have to have our Phong lighting and everything, so we're going to have to add it to it. And then so now we need to do our normals across the surface here for its distortion of the surface. So norm.x here times in.twn, and our in.twn is our tangent. It's in world space coordinates. It's been normalized. And then we're also going to add the normal plus y, so our normal y here, times in.bwn, which is our binormal here in world space coordinates. It's been normalized, semicolon. Okay, cool. In dot nwn, this is our normal space in world coordinates. It's been normalized, equals normalized here, open parentheses, in dot nwn, close parentheses, semicolon. And here we are then normalizing the finalized normal in world space coordinates. It's been normalized that we get results. So essentially what we're doing is we're taking the resultant that we got from our bump map operation and our modification to it by strength here, and then we're adding it to our actual normal. Okay, and so we're adding the part for the x contribution and the y contribution of that normal map, and we're not bothering with the z contribution currently. Okay, so lit v here, and this lets us handle our good old light vector here. This lets us do our specular and our diffuse channel for the Phong shader here. So remember, this is this optimized function that lets you do that, and it returns back our, we don't care, this is always 1.0 here, so we're not going to care. I really wish I would remember not to put that thing in there. Alright, there we go. And then, you know, if you have this moved over into here, please don't move it from out of this function into this function here. Leave it where it's at. And also, if you have it being used up here, don't remove it, because that's a better method than what I'm doing here. Really should go back and fix that. I think I will later. Okay. Not in the video, just in my own time. It's a simple matter. If you've been watching these videos, it's really easy for you to switch that around. Float 3 here, ambient equals ka.rgb times global ambient.rgb semicolon. Float 3 diffuse equals lit v.y times lamp 0 color semicolon. We're doing our diffuse here. Now we're setting up our specular now. Float 3 specular equals lit v.y times lit v.z times ks.rgb times lamp 0 color semicolon. And then diffuse color here, float 3 diffuse color equals text 2D here, open parentheses color sampler, because we're doing our diffuse texture here. in.uv close parentheses .rgb here, semicolon, and then float 3 here, r equals negative reflect here, close parentheses in.vwn comma in.nwn close parentheses semicolon. Float 3 here, reflect color equals our kr times our text cube here, open parentheses emv sampler comma r.xyz close parentheses .rgb semicolon. So again, this sets up our reflection angle from the view, which actually does our reflection vector, which causes this beautiful reflections here. So we're calculating what angle it's going to be hitting at and whatever for our vector, and then we're using that to do the lookup for finding the pixel that we need to find, okay, or based on that reflection vector, on the surface of the texture. So we're using that for a lookup part on that. And then the KR here is just controlling the strength of the reflection. So how much of a contribution this is going to make to the actual overall pixel. Okay, and then the last part right here is just our out color here. So out.color equals float4 here, close parentheses here, and then specular here plus open parentheses diffuse color times kd.rgb times open parentheses diffuse plus ambient close parentheses plus reflect color close parentheses comma 1.0f close parentheses semicolon. And then we're going to come down to the next statement. It's going to be return out semicolon close curly brace here, and then comments here for the techniques. All right, and so we have technique here, space technique 0, open curly brace here, pass P0, open curly brace, depth test enable equals true. Yes, we're going to do a depth test. Depth mask equals true, semicolon. Cull face enabled equals false, semicolon. Blend enable equals false, semicolon. Depth function equals L equal, semicolon. Vertex program equals compile VP30 space main VS open close parentheses semicolon. Yeah, we can get away with the VP30 on this one. Fragment program equals compile FP30 main FPS here open close parentheses semicolon close curly brace close curly brace. And there we go. That will be the Phong normal reflection map shader. All right, so take all this code, this whole thing here, and copy it. And then come up here to create effect. Then you're going to choose CGFX. Next, empty again, and then name it. And name it something like Phong normal map, or Phong normal, or something like that. I don't care. It'll be something like that. So select that, and then say next to create the next one. Then you're going to come over here to this one, and you are going to paste it in. So with that, right click, and then say paste to paste that whole thing in. And there's not much difference here. We basically just need to remove the reflect aspect of the shader, and then we're done. And then you'll have your normal map one. And just as a show of what I'm talking about, that'd be this shader here. So now we're going to do this one right here. And it's really simple. Like I said, we're just going to remove that reflection component. You had it from previously, so hey, why not, right? Okay. So going on down through here, we no longer need the reflection one. So everything's the same. Going through here, and oh, I just changed the name here. So it's a Phong reflection shader with normal map. So we're going on down through here. Ambient light here. All the way down to normal bump. Remember to remove the KR annotation here because you no longer need it, because we're not going to have the reflections as part of this one. You come down here and you're going to remove your environment reflections map, cube map here at the bottom. So the annotation for the actual texture itself and the environment sampler, remove both of them. So yeah, remove the environment texture and the environment sampler. All right, so in and out parameters here should look like this. So you're going to remove anything you would have for reflection in there. This one also struct VS out here. And come down through here, and you're going to remove anything for KR or KS. Anything that would be far as reflections go, are going to get removed from this thing. And this is the same. And then, well, everything else is the same basically. This is all the same here. This does not change. This over here, like I said, it'd be best if it was moved up into the vertex, but whatever, it's the same throughout all this part here, all the way through here, including here. Just remove the KR part here. So I'll just real quick show you what to remove. Essentially, yeah, just remove this part right here. So you should end up with this, right here without that there. And once that's removed, you have your diffuse texture color thing right there. And then you just have this statement here for your color out. Fairly simple, really. Same as always, really. So you're just going to have float 4 here, specular plus open parentheses diffuse color times kd.rgb times diffuse open parentheses plus ambient close parentheses comma 1.0 f close parentheses here. Return out, close semicolon here. Come down to our technique here. Technique 0 here. Open curly brace pass P0 here. Open curly brace def test enable equals true semicolon. Def mask equals true semicolon. Call face enable equals false. This stuff doesn't change. It's all the same here. Blend enable equals false semicolon. Depth func here L equals semicolon. Vertex program compile VP30 here main VS open close parentheses semicolon. Fragment program equals compile FP30 main PS open close parentheses semicolon. Close curly brace close curly brace. But essentially, there we go. So that is pretty cool. And that will give you our normal map shader. And like I said, yeah, so this is the only thing I would change up for moving that over into here, just to make things faster. There's no reason you need to do it over here. But with that, that's all really. And that covers how to do some normal map shaders. Later on, we'll look at doing parallax shaders and doing the relief shaders. We're also going to do some screen space shaders coming up here soon, and some other techniques and stuff that are really cool. We're going to do several good screen space shaders. It'll be a whole slew of them. They're a lot of fun and they look really good. And we're also going to do a bunch of light models too. So we try to hit all the light models that are important out there. So we're going to do that. We'll also cover shadows, how to do shadows, how to share the shadows, how to do soft shadows. We're going to do all that. We're just going to keep doing more and more of these awesome shaders, just so that you can be familiar with the techniques, how they work, understand the theory underneath it and everything, so that when you need to make your own shaders and things of that nature, then you will know how to go about it, and you'll have a good solid foundation on how things work, and then coding and developing this stuff will be a lot easier. Alright, so with that, my name is Nate Nestler, and this has been CG Shader Programming, and this is for Hyperactive Studios. Thank you very much.